This is question number 18 on the November 2014 non-calculator paper. So in this question, you could see that there's a series of shapes, and let's see what they've said. A, B, C, D, and A, E, F, G are mathematically similar trapeziums. So we're talking about similarity here. They've given us the distances. AE is 5, EF is 12, and BC is 18. And they've given us that information on the diagram. Work out the length of AB. So we want to work out the length of AB, the distance all the way across. The word that gives away what you need to do in this question is the word similar. Okay, so I'm going to break this question up. I'm going to draw two trapezium, right? I'm not going to make it a work of art, but I'm going to split those two trapezium up. This one, AEFG, and ABCD. Okay, we know this is 18 in the big one. This is 12 in the small one. I know this distance here is 5, and this is AB in the big one, which I want to work out. That's what I want to work out. And now it's a bit more apparent of exactly what I need to do. Okay, so I need to work out the multiplier that takes me from 12 to 18, and then use that to help me work out what AB needs to be. So the multiplier is going to be 18 divided by 12. Okay, in other words, 18 over 12. Now that's not particularly straightforward, but I could simplify that fraction. I could write it as 9 over 6. I could divide both of those by 3. I could do 3 over 2. And 3 divided by 2, that's straightforward. That tells me my multiplier is 1.5. So if I did 12 times 1.5, that gives me 18. If I do 5 times 1.5, that's going to give me the length of AB. So AB is going to be 5 times 1.5. 5 times 1 is 5. 0.5 of 5 is 2.5. Add those together, that's 7.5. And that's my answer, 7.5 centimeters. Okay, if you're familiar with similar shapes, this would be a straightforward question. You need to make sure you are familiar with it. It's a common type of question, and you should be able to get it. Let's look at part B. In part B, they've said trapezium AEFG, the smaller of the two, is 36 centimeters squared. Work out the area of the shaded region. So the shaded region is the bit between them. But if I draw my sketches again, so this being the small one, and then the larger one, okay, they've said to us that the area of AEFG, the smaller one, is 36 centimeters squared. We know our multiplier, our scale factor for length, is 1.5. The scale factor for area is going to be 1.5 squared. Now you need to know what 1.5 squared is. I know that 15 squared is 225. That's one of the square numbers you should know. So 1.5 squared is going to be 2.25. Okay, you should know that. So that's going to be 2.25 is my multiplier. So the area of the larger one, so its area is going to be 36 times 2.25. Okay, now that is not particularly tricky, right? It's two lots of 36 plus 0.25 is a quarter of 36. A quarter of 36 is 9, right? 36 divided by 4 is 9. So that's going to be two lots of 36, 36, add 36, add 9. Two lots of 36 is 72. 72 add 9 is 81. 81 centimeters squared. going back to the question itself, it says work out the area of the shaded region. So if we go back up to the diagram at the top, the shaded region is just this bit here, right? So I need to take away the area of the small trapezium from the area of the large trapezium to work out this shaded region. And so I'm going to do that maths over here. I'm going to say 81, which is the area of the large one, take away 36. That's going to give me the area of the shaded region. So 81 take away 36. Need to borrow 1 from the 8, so that's 7, carry 1. 11 take away 6 is 5. 7 take away 3 is 4. That's 45. I'm just checking that. Yep, that's correct. So 45 centimeters squared is the area of the shaded region. Okay. Now, this second part is not a straightforward question. However, the maths that you need to do is pretty straightforward. There's a lot of tricky number work, right, that can cause you to slip up. If you take your time, you should be able to do it. Think about the maths, break it up into stages, and make sure you can get full marks in it.